inequalities. We're going to be looking at our problem that has the garden problem, and I'm going to make that a little bit bigger font so you can see it a little bit. Maybe not quite that big. So we have, let's read the question first. It says, how many plants and bags of soil can she purchase? So what we're looking for is how many of something. I'm going to underline that using my underline tool up here at the top. Then we're told Marcia is buying plants and soil for her garden. The soil costs $4 per bag and the plants cost $10 each. She wants to buy at least 5 plants and can spend no more than $100. So some things that are important of this to be able to find how many, we know how much each of the items cost. You see soil costs $4 per bag and plants cost $10 each. So I'm going to highlight that and make it yellow. Whenever you see the word per or you see the word each, those are rates. And so those are going to be our numbers that are going to go with our variables in this case. She also wants to buy at least 5 plants. That's one of the limitations of what we're looking at. That's going to help provide us with a boundary. And that she can spend no more than $100. So I'm going to highlight that and make that green. So these pieces of information are what will help us to be able to write our equations. On the next slide, we're going to define our variable. So defining our variable, I'm going to be defining x is equal to something and y is equal to something. So if we go back to our question, we see that we're looking at how many plants and how many bags of soil. I'm going to use the order they were written in up here to help me write my inequalities, my variables. So I'm going to use x is going to represent the number of bags of soil. And then if that's the number of bags of soil for x, then y is going to be the number of plants. So those are my two variables. For our writing our inequalities, we will use the information that we're given in our paragraph. So we know how much they cost, and we also know how many plants we need to buy. So we're going to use the cost, and we're going to also use the number of plants as our help for writing this. So how much does it cost? We know how much each one of them costs. We could take this sentence right here, and knowing our variable definitions, we can use that to write our first part of our equation. We know it's $4 per bag of soil. Soil was our x value, so we say 4 times x. And then $10 for each plant. So we could say plus 10y. So I'm going to write that out under here under my cost. So I have 4x plus 10y. And if we look at the amount we're allowed to spend, it says no more than 100. So if you looked on your yellow sheet, no more than 100 would be the same as less than or equal to. So I am going to use my underline tool to make that look like our less than or equal to. So I use the underline and I use the side arrow button, less than or equal to, turn off the underline, 100. So this says 4x plus 10y is less than or equal to 100. Then, for my other equation, the limitation on the number of plants, it says she wants to buy at least 5 plants. So plants was our y variable, and at least is under the under the greater than or equal to. So I'm going to underline this and put greater than or equal to. Turn off my underline tool after I get past that. And she wants to buy at least 5. So it's going to be y is greater than or equal to 5. That's how we wrote our equations. Defined our variables and we've written our inequalities. We're going to go on to slide number 4, which is going to be taking us to sketch our graph in Desmos. And then we're going to find our point of intersection, which actually we can have multiple points of intersection. So opening your Desmos, I'm going to type in my two inequalities. So my inequalities are 4x plus 10y is less than or equal to 100, and y is greater than or equal to 5. So I'm going to type in those separately. You can't just copy and paste it because the underline function or format doesn't seem to copy, it doesn't understand it. So I'm going to use my keyboard here. I can type it in. I say 4x plus 10y is less than or equal to, which is right down here at the bottom, 100. And that gives me this part of the graph. The other thing is the other equation, going back here, I have y is greater than or equal to 5. So I'm going to type that in. Y is greater than or equal to 5. Now I have another plane on here where I have the intersection happening. But we want to go ahead and make this graph make some sense, so we're going to label the axes. So go over to the gear in the top right corner of your graph, and we're going to label the x and the y axes. So if I go back to my definition of my variables, x stood for our number of bags of soil. So I can type in here bags of soil. And then my y-axis stood for the number of plants. So I'm going to go type in here number of plants. And it shows up on my x and y axes. Additionally, we can think about the fact that I can't buy a negative number of plants and negative number of soil. So all the space that's outside the first quadrant, or to the left of the 0 on the x-axis and left on the 0 on the y-axis, those don't qualify. So I'm going to use this curly brackets, which let me go ahead and change this over so we can see what this is going to look like. So I have curly brackets down here, or you have them on your keyboard to the left of your, to the right of your letter P. So I'm going to do curly brackets. Y is greater than 0. Close those curly brackets. And then I'm going to do curly brackets. X is greater than 0 also. So that made my graph so that it ended up being sort of a triangle and didn't go beyond the x and y axes. So I'm going to do the same thing on the other inequality. So y is greater than 0. And x is greater than 0 also. So now my graph looks something like this. So it doesn't go beyond the x and the y axes. Now, when we solved for a system of linear equations, we were looking for a place where we had two lines that we had two lines that overlapped. So if I look for a system of linear equations, let me find one for you. Or I can just make one really quickly. If I said y is equal to 5, and I said x, we'll say 4x plus 10y is equal to 100, we have two lines and they're going to cross in one place. And we have that point of intersection, right? Where that would be our ordered pair that we would end up with. We're going to actually have the ones that we're looking at where we have a blue plane here, oops, and then we have a red plane there, and we're looking at the place where they overlap, and we're finding a point on the graph where those two overlap. And if I look at it, I have a lot of possibilities there. So I can use the points 6, 3, does that work? Nope, not quite. How about 6, 8? Not quite. How about 6, 7? Yep, and I can check the box, and that's going to be inside the area that's going to be included. And then I could also do another point, 10, 5. That one's a solution. So I have lots of areas that are going to be inside of that space. We have several points that are going to work for this. We can do as many as we come up with, as long as they're in the parts where we're overlapping. So I'm going to, for all intents and purposes, we're going to use the point 10, 5. So we've got our axes labeled, we've got our two ordered pairs, or an ordered pair on here, we've got our two inequalities typed in. Now we're going to export this into our Google slide. So go up here to the Share where it's on the top right corner. Click on Share Graph. Then we're going to click on Export Image. change your line thickness to medium, and download PNG. And how you have your graph sort of aligned and on your screen, it's going to help you with how it's going to line up and look like on the output. So I'm going to go back to my slide presentation. I'm going to go to the image icon. I'm going to upload from the computer. I'm going to click on my Desmos graph, and we're going to size it so it fits inside the space over here. Now I'm going to identify what was my ordered pair that we had plotted on the graph. In our case, we said we were using 10, 5. So I've got an ordered pair. That's not the only ordered pair that's possible. So when you do your other ones, you may end up with a multitude of other options as long as they're whole numbers, because you can't just go in and buy a half of a plant or half of a bag of soil. So to verify our solutions, we're going to take our inequalities. I've got my first inequality of 4x plus 10y is less than or equal to 100. I'm going to drop that into my first space. My second one, I'm going to take y is greater than or equal to 5, and that's going to go into my second space, and we're going to go ahead and do the verification process. So in order to verify, I need to take out the x and the y, and I'm going to drop in my ordered pair. So where I had x, I'm going to put in the number 10 plus, so 4 times 10, plus 10 times I put in for y was 5, and then less than or equal to 100. So I'm going to keep simplifying. 4 times 10 is 40, plus 10 times 5 is 50, is less than or equal to 100. And I'm going to keep going with that. I'm going to make this a little bit smaller because it's getting too big for my screen. So 40 plus 50 is 90. 90 is less than or equal to 100. So that checks out, that is true. Let's do the other side. This time I don't have any x, so I only need to replace y. And y is, it's 10, 5 is my ordered pair. So 5 is my y, is less than or is greater than or equal to 5. And that is true because y, 5 is equal to 5, and 90 is less than 100, so that works. Down here at the bottom, we're going to write out the meaning of our solution. What it means for the ordered pair 10, 5 is that Marcia can buy 10 bags of soil, because soil represented our x value. That was our x value for that ordered pair. And 5 plants, that was our y value, to stay under $100 and have at least 5 plants. That's how we write our verification. So your measure of success was to be able to verify your solution, which we did on this slide, and then to explain your solution, what it means. What does the ordered pair of 10, 5 mean on the number line or on your graph. Once you've done that, then you're finished with that whole entire problem, but you need to make sure you include the context of what explaining your solution means.